I'm just going to take a couple of housekeeping items here before we get started. So the program is going to be in 4 sessions. Each session will build upon the other. So forgive me if this first session may be a little bit repetitive for some of you who have a little bit of experience, but I just want to set the context and get everybody at a ground level, and then we'll start building from there. I will be going through some of the course agenda in a minute. As Rob mentioned, we're going to be recording these sessions, and because one session builds upon the other, if you want to go back and review the session, or for anybody that may have missed a session, they can go back and get the recording and then catch up for the future sessions. Q&A, just ask a question. So we'll keep this free flowing and open. If something comes to mind, you want to ask a question, by all means do so. You don't need to wait to the end. The other thing that we're looking at, just so you know, is toying around the idea of having, at the end of the session, having an astrophotography evening at a park, local park that has some kind of clear horizon. It may not be totally dark, but to give some personal instruction on astrophotography. So you can bring your equipment there. We can have a look at it, your equipment set up, and do some, astrophotography and help you with that. That's something I'm toying around the idea. I don't have any dates in mind yet or anything like that, but I think that might be valuable. Hopefully you agree. Okay, so let me just get into the program here. So the course structure, as I said, there's going to be 4 sections, 30 minutes to an hour each. Again, covering the basics of astrophotography. So this is not an advanced astrophotography workshop. I mean, literally, you could go on and on and on. There's so many aspects of it. So you have to carry some boundaries when you're starting from ground level. We're going to be learning various methods in this course, from all the equipment you need and the knowledge base that is required, to finding objects, to focusing on the objects, right to taking your first photographs. But there are some assumptions that we want to be aware of, and I'm not going to be teaching in this course, and that's the basic understanding of the night sky. So celestial coordinates, constellations, and major stars. I'm really not going to be reviewing any of that. So if one of the things I tell people when they're getting started is the best thing you can do is grab yourself a star chart and get to know the night sky before you start photographing too much, because you just won't have a bearing of where you are. So I'm making an assumption that you know that the night sky, the constellation, major stars, what the celestial equator is, the meridian, and right ascension and declination coordinates, because we will be talking about tracking drives later on, and that comes up. So I don't want to have to go through all the rudimentary components of that and all the various things that need to know. That would take a long time. So the objective is to establish good techniques and learn enough to get started with nightscape photography. So I'm talking about photographing constellations, star trails. You saw my first image there. I was on crepuscular rays, which is a phenomenon created by the setting sun and certain things in the atmosphere, and that's a very basic photograph, but there are certain aspects to that. Lunar photography, and predominantly using a lens and a DSLR camera. So I'm not going to be covering off prime focus photography with telescopes, auto guiding, guide scopes, off-axis guiders, dedicated astrophotography cameras, dual axis guiding mounts, mono imaging, multiband filters, planetary imaging. Those may be considered for future courses, and there's quite a lot of material that one would have to go through. So you really need to have a ground level understanding and skill set with astrophotography before you jump into those things. I've seen a lot of cases where people just buy a telescope and some fancy equipment, put it all together and try to take astrophotography. And what they quickly find is that it become overwhelmed, or their first few results, and they plateau very quickly. because they haven't established some other techniques. We aren't going to be covering image processing either. So that's a whole nother thing. And even with basic astrophotography, there is some image processing required, but not a lot. Any questions on that? Okay. So this may be basic, but what is astrophotography? Well, it's the recording of the sky with the intent of capturing by digital means, in this case, or otherwise some celestial object and or background sky. So it's very broad. So what I'm saying, it could be anything, a nightscape with or without interesting foreground. I mentioned that because some of the best photography that you will see has some really interesting foreground objects that's lit up a bit, and it really enhances the quality of the photograph. So that's something we will be talking about during this course.
The best astrophotography has a hippo in the background.
There's a hippo in the background.
Hippo in the background, oh yeah.
Oh.
If you look at Jake's picture, I'm sorry.
Okay. All right. All right. I gotcha. Is it okay now? Can you see the chart okay? Is it all right?
Oh, yeah.
Okay. Star trails. So again, there's lots of elements with regards to star trails and looking at what you can do to set that up. Wide field Milky Way photography. Wide field deep sky object, or what I call deep sky region, because we're going to be talking about photography with a DSLR and a lens. It's going to be wide field. So I consider those deep sky regions. And there's, of course, all kinds of things in consideration when you start looking at deep sky regions, deep sky object photography. Lunar and lunar eclipse photography, solar photography, H-alpha and white light, planetary, solar system, comets, and deep sky objects. We will only be covering off night sky, star trails, Milky Way, and the wide field DSO, DSR, and lunar. I will not be talking about solar, planetary, comets, or deep sky objects. That's for a future program. Questions? Cool. Okay, skills required. It's a lot easier now because we have the internet to look and gather information on events. One of the things with regards to astrophotography from the get-go is planning, and we'll be covering that quite a lot in this course in terms of getting information, looking for interesting celestial events, like there was one yesterday, for example, if you were in clear skies, where we had the crescent moon, Jupiter, Uranus, comet Brooks, and M45, the Pleiades, all in a 6 or 7 degree field of view, which was quite phenomenal. If you had clear skies, that's the kind of thing I'm talking about, looking for unique celestial events that could make interesting photography. And all those resources are easily acquired on the internet or with planetarium software. Understanding the night sky, and as I mentioned before, to really get a good idea of all the constellations and what you can see in the sky, just go outside in the backyard or park or whatever. And I would encourage you all to spend some time just looking up and identifying the constellations and the major stars. And once you really have a good understanding of that, it makes things so much easier in terms of photography later on, trying to find objects, or if you're looking at planning up your session, you'll know exactly where you need to look. A lot of time can be wasted by trying to find something that is of interest to photograph, and you can't identify where it is. So really to me, that's from the get-go a very essential part of astrophotography. The other skill required is you need to have an aptitude for photography. So if this is your first attempt at photography and you choose astrophotography, that's probably not the way to go. You should have a good understanding of your equipment, how to use it, how to take good photography, lighting, focus, the settings of your camera, all those kinds of things you need to have a good understanding of. When it comes to astrophotography, you're going to be testing that to the limits. Also, with regards to settings and ISO, and we'll talk a lot about that later on, the impact of ISO. I see a lot of people setting up their cameras and going for like right out of the gate 3200 ISO or high ISO. And those aren't good habits to get into, because they introduce a lot of noise that you really don't see until you start zooming into the object, and it really takes away from the photograph. So those are little techniques we'll talk about later on. They're tempting because you think you can shorten your photographs by taking highly sensitive or very high level ISO settings and increasing your sensitivity, but your noise goes through the roof. And I really don't care what camera you're using, they're all suspect for that. Technical skills, so understanding how computers, your file formats, JPEG, FITs, raw data, all those kinds of various CR2 raw files, those kinds of file formats are going to be important to understand, and how much computer or how much memory space they will take on your drive. We'll be talking a bit about that. My preference in all cases is to photograph raw. And I think a lot of you would understand that, but you don't want any compressed data. Given the cameras that you may be using, you may be talking about gigabytes when you're finally completed your image. So you need to be cognizant of the storage space required. The artistic, and this is something I think that comes with a lot of experience. So out of the get-go, I wouldn't expect you to have a lot of sense of creativity for that matter. It builds up with your experience over time. But if you're taking a photograph and you're studying the area around you and you're wanting to set up a scene, looking for certain kinds of lighting, what nature has to offer around you, and looking for that ability to bring some more artistic flair with regards to your photographs is really enhances it. Again, organization and planning. So when you get out to the field or the location and you start to do photography, the organization and planning, that's not the time to do it. The time to do that is before you go out, decide what you want to photograph, where it's going to be in the sky, what the conditions would be. Then you can do a site survey. And again, we'll be talking a bit about this, a site survey about where you're at and how to set up your frame and all that kind of stuff. So organization and planning skills are very important. You want to be persistent, because the first few times that you go do this, you may not be happy with your results. This takes a lot of trial and error and a lot of practice, as you know. And so if you have a don't quit attitude and a persistent nature about you, you're going to achieve better results. Celestial coordinates, right ascension and declination. If you don't know what those are, look them up. I'm not going to be reviewing that, but they're essential to know. There's a lot of cases where I've had to photograph objects that are actually in databases. So I do research and I have to get RA and DEC coordinates and then find a way to dial those in as close as possible without a go-to mount. I'm talking about just a regular type of manual mount. So understanding RA and DEC is going to be very important for you, especially if you do photography that requires longer exposures. The meridian and the celestial equator, you'll want to know what those are exactly. So I'm not going to be reviewing those. Look them up if you don't know. And then patience and perseverance. As I mentioned before, you have a persistent nature. Patience and perseverance are your friends with astrophotography. Any questions on that? All right. So let's talk a little bit about understanding the night sky. And for most of us here, since we live in the northern hemisphere, we're talking about the pole star and Polaris. So that is your friend. Whenever I go out, it doesn't matter what kind of photography I'm doing, first thing I'm doing is looking up where is the pole star, and then I use that as a reference for everything else around me, not only for polar alignment, which we'll talk a little bit about later on, but just as that's my reference point to everything. And if you're in the southern hemisphere, the closest to that point would be Cygnus Octantis. We don't have to worry too much about that here, but if you're ever doing photography in the night sky, you have to keep that in mind. The internet and planetary programs make it easy to learn the night sky, and we have a great program called Stellarium, which is, if you don't have it on your computers, you might want to get it. It's a free download, and you can set that up in a very basic mode, and that you can learn all the various constellations and the major stars in each of those constellations. And from there, you can get your references for what you want to photograph. But I highly recommend a program like that. As I said before, identifying primary marker stars for the constellations. So, and in particular, the constellations that are visible to you for your location, not all will be, that you think are there. You have to look at your conditions, light pollution, and what's around you to identify what constellations are there. And once you find those marker stars, it becomes very easy to then start identifying the location of objects that you may want to photograph. Understanding of astronomical twilight and darkness timing. So there's a big difference between dark and really dark. So for astronomical twilight, we're talking about an hour or more after the sun sets. And for astrophotography, I typically would, and if you're really wanting the effect of more contrast and photographing objects that may be a little dimmer, you want to probably add another half hour to that. So an hour and a half minimum after sunset is when you might want to attempt night photography. Some people will do it earlier than that. Some people will wait till later. It all depends on what you're trying to photograph. The photograph I had at the beginning of the presentation with corpuscular rays, that was done at about 20 minutes after sunset. And you had this very nice effect, but that's what I was going for. Typically, I would wait till at least an hour and a half, even up to 2 hours after the sun sets, in order to start taking photography. So when you're planning your session and you're going out, say, in July, and you're looking at an hour and a half or so after sunset, it's quite late at night before you can even attempt the photography. You're talking probably 10 o'clock minimum before you should start attempting dark sky astrophotography in the summer. In the winter months, up until about March or so, you can get away with 9 o'clock, 8:30, 9 o'clock, but in the summertime, it's after 10 o'clock. Just so if you're looking at objects that you want to photograph, you're looking for times after that. Again, it's the type of photography you're going for. Understanding locations of deep sky objects and deep sky regions. Again, programs like Stellarium are going to help you identify those objects. I would stay away from photographing those kinds of objects until you have a really good understanding of the night sky. You will spend so much time trying to find and focus those objects if you don't know a really precise location. And I know there's go-to mounts and all that kind of stuff, but when you're starting out in astrophotography, it's good to really use manual equipment and get a familiarity of the sky and not depend on that technology to help you find things. And I know people would argue that, but it becomes a lot easier later on when you do have the technology that you can use if you have those skills already in place. Coordinates, Alt-Az, and RA, I already mentioned those. So these are some of the things that you'll need to learn with regards to the night sky before you really start getting into astrophotography. Sure, you can do a star trails photograph by pointing your camera at the pole star and set a bulb setting on your camera, open up the lens, open up the shutter and walk away. You can do that. But if you can combine other elements of that, like artistic presence and things that are around you, that all of a sudden becomes more interesting. If you don't wait long enough for astronomical twilight, your photograph might be ruined. So these things each have their own importance with regards to all different aspects of astrophotography. Any questions on that?
I got one question.
Yes.
It might be a little noisy, but when you're taking any pictures at night, do you go there with a goal for one specific picture, or do you go out there and kind of try and take multiple, whatever you can get?
Yeah, very good question. So the temptation is to try to do as much as you can to make best use of you think of the night by taking multiple shots. It all comes down to your planning. It comes down to what object or what is it you want to photograph. And I'll give you an example. If you're going to do star trails and that is your objective, you're going to have to ask yourself the question, what kind of star trail photograph am I looking for? Do I want very long trails or short trails? What am I trying to photograph? And is there an object that comes into view that is going to be tracked through that? Versus something like Milky Way with an f2 lens. You're going to need probably a couple of hours of exposure time on the star trails versus 5 or 10 minutes on a Milky Way shot. So it all depends on what you're trying to go after. And the other thing too is not to rush the setup and to make sure you've got everything properly planned and everything else. And so I would say that you probably don't want to chase too many objects especially when you're just starting out. You want to stick to like maybe one or two for an evening and take your time and do a good job of it. When you go back to your home and you're processing and everything else and you have good data, then you'll really appreciate that you took the time and the effort to spend on that object and that scene, and you'll be much happier rather than looking at 4 or 5 different objects that didn't turn out that great. So that would be my suggestion. Make sense?
Perfect. Thank you.
Okay, thanks. Okay, the tools you're going to need. Well, we all have a keen interest. That's why we're here. So that's a given. You want to have a sky atlas or planetary software. I use both. I have 4 or 5 different planetary softwares. I don't know why. I just grew up with that way, and each do slightly different things. But Stellarium is a pretty good planetary software. But when I'm out in the field, I don't like carrying computers with me. So I'll have a set of sky atlases. And I started out with I started out with my own eyes and a pair of binoculars for 3 years before I even attempted astrophotography. But I would go with I had a Sky Atlas 2000. That's what I used, and it was laminated. There are many different Sky Atlases out there, but I would really encourage you all to look at investing in a good paper version of the Sky Atlas and taking that out with you, at least for a few times, to look at the sky and look at the atlas and see if you can picture your atlas with the sky. So you get what that does, it allows you to immerse yourself into the whole experience and take in everything that's around you. And once you start doing that, you'll be amazed at how quickly you start being able to pick up reference points across the sky. Planetary software, you know, you plug in your laptop, you bring it with you, then all of a sudden your night vision is gone. So I would really invest in a nice set of the Sky Atlas charts, and ones that are laminated, so when it dews out, you don't get the pages stuck together and stuff like that, and go for the field version. So that would be my recommendation. It's probably one of the most important tools you can have. Of course, you need access to equipment like a DSLR camera or a smartphone, but we'll talk a lot about that later on. When it comes to other equipment, in terms of mounts, and I'm talking about tripods and star trackers, you need something really solid. So for visual astronomy, you know, people will tell you get a solid mount. For astrophotography, you're going to double that, because the wind and everything else is going to wreak havoc on your photograph. So you need something really solid. I don't mean to be like super heavy, but it has to be like really solid. Like I wouldn't cheap out on that. Like Manfrotto mounts, good solid Manfrotto mounts as a baseline to get working with, as what I would recommend. There's a whole host of star trackers. We're going to go through that later on in more detail. I would stay away from go-to mounts to begin with. They're actually more trouble than they sound to begin with, because if something goes wrong, you're messed up. There's a lot of other components like adapter plates, batteries, dew heaters. We're going to cover that a little bit later on, and a host of other equipments like flashlights and you know, notebooks, those kinds of things, which I'll talk about as well. Lenses. Obviously, you're going to need a lens, telephoto or a zoom lens. My preference is a telephoto lens, but there are some excellent zoom lenses out there as well that you can look at. For this course, we're going to stick to the 18 millimeter to 200 millimeter range. Nothing beyond that. Once you start getting beyond 200 millimeter, then your tracking and guiding considerations are substantially more impactful on your photograph, and we're going to get into a whole bunch of other things. So we're really keeping to that type of range in terms of focal length. And then we're also going to talk about types of lenses later on, quality of lenses. There's a lot of misinformation on the internet with regards to lenses and what's a good lens and what's not a good lens. And we're going to try to try to get you guys on the right footing when it comes to lenses. You probably already have a collection of cameras and lenses, but try to talk about the kind of lenses that you really should be looking at. You want binoculars, a good set of wide field binoculars. They're multi-coated with roof prisms, and something lightweight and decent, because when you're actually going to be photographing an object or you're looking at the sky, binoculars will give you a good sense of where you are, help with your reference points, and they're fun. I mean, sometimes you're photographing an object and you're having to track that object for quite a few minutes. Good opportunity to pull out your binoculars and just explore the sky. I do that all the time. And then you want a computer with, you want to be able to manipulate file formats. We talked a little bit about this before, but some of the DSLR cameras have their own raw file formats. The one I use, Canon CR2, there's FITs and TIFF files and JPEGs and on. And you want to have software that does that conversion. Otherwise, it'll become quite difficult later on to do some rudimentary processing. Any other questions on that? You also want to have, and I didn't mention it in here, something to allow you to be comfortable. So, and we'll bring that up again later on, but something comfortable to sit on, obviously tables, warm clothing, dress for the conditions you have, and then add another layer to that. Because when you're out in the night sky for hours on end, it can get damn cold. And if you're cold, you're not going to take good photographs. So you have to really be comfortable with your, your personal situation. Okay, I talked a bit about the equipment consideration and the sky and the planetary software Stellarium, and the Sky Atlas. There's a few other things here to mention which are invaluable. And there are a number of weather apps. And when I say weather, cloud forecasting apps that are on your phone, I'm sure you have some of these already. There's Clear Sky Clock, which I know many of you are probably familiar with. There is another version of that called Clear Sky. It's an app, and you can get it for Android or iOS. I find it more useful than Clear Sky Clock because it actually gives you percentage of the cloudiness at different layers. And why that's important is that even though you have a clear sky and it'll tell you the level of transparency, which you can do with Clear Sky Clock, but it gives you a little bit more gradation in terms of what you're actually seeing. So that's an excellent program. If you haven't got that one, check it out. It's free. So, and I'll have some information on about that later on in a next session. I'll get some screenshots on that. There's another free app called Atmospheric, and some of you probably know this one as well, but it shows you the cloud forecast in your area or a visual representation based on satellite images, and it'll give you different levels of the cloud layers. So you can work your way through the cloud layers and see what's in your area or what's coming in your area within the next 2 hours. So really useful in terms of planning, and depending on what you're going to be able to see that night, what the sky conditions are going to be, and therefore what you think you can photograph. Unfortunately, we live in a climate here if you get a clear night the whole night long, like really good transparency, that's a rare thing. That doesn't happen that often. Doesn't mean you can't take photography when the sky is less clear or less transparent, or for shorter periods of time. You just use these tools to help you with the planning. There's a hand raised question.
Yeah. Is that astrospheric?
I think it's atmospheric.
Yeah, not astrospheric, because I have used
Maybe it is.
astrospheric.
It could be.
I just don't want people to go looking.
Yeah, no, good point. Let me just look on my phone right now because you could be right. I'm not the best at spelling and grammar, as you noticed. Astrospheric. I'm sorry.
Okay, I used it on Monday.
Me too.
Yeah.
And it was actually very accurate. Now it was very sad.
Yeah.
Damn, it works. Anyway, so there's a few other apps that we're going to talk about in this course as well that are they're free apps. The Optron app, there's a Polar Sky Alignment Pro. It's really good. It has all kinds of cool stuff on it. All right, camera. So I brought it. I put it in here for a matter of completeness, but I'm not a big fan of smartphones photography. But you can do it. Probably works better with prime focus stuff than wide field. But there's smartphone adapters which you can get quite inexpensively, and they'll work. But the problem with smartphones is most of the software and the hardware in your camera are compromising. In other words, they're not designed to give you a lot of flexibility in what you're shooting, and they do their own filtering before they read out the data and all that kind of stuff. And I'm just not a fan of using smartphones. And people can argue with me, but I don't. So during this course, I'm really going to stick more to DSLR photography. And with DSLR, there's two ways to look at that. You're either talking about a crop sensor or full frame. And there are debates on both sides. They're both excellent to use, but full frame will just give you that a little bit wider field of view than a crop sensor. But the way I look at it is, if you decide to use a full frame versus a crop, what ends up happening is you'll end up cropping the image anyways, because at the extreme edges, you will notice that regardless of almost any lens you're using, you're going to get distortion and you will get vignetting. So you end up with a crop sensor anyways. So I really debate the whole, unless you're working with a Takahashi type of telescope, which is 10 grand and you have everything high end, you can get away with it. But if you don't, personally, I would stick with a crop sensor. Anyways, you want to look at the chip that's used in your camera. Not all DSLRs are created equally. A lot of them are using standard Sony chips now, which seem to be the industry, standard to go with for astrophotography, but there's many other chips out there that are very good. Canon and Nikon seem to be the leaders when it comes to making cameras that seem to work pretty good for astrophotography. There's some work you need to do. You also need to be aware that when you're looking at specifications for a camera, they will purposely hide certain specifications from you. Why? Because in the manufacturing process, it's really hard to develop those kinds of cameras. What I'm saying is that specifically when it comes to a read noise based on the ISO. So you will find that the noise on certain cameras, as you increase the ISO, is really bad, even if it's an expensive camera. And you won't find those stats very easily if you look on the manufacturer's website. And that's why I said before, when it comes to ISO, a lot of people said, well, I'm going to shoot at 3200 or 1600 or 16,000 or whatever. And I'm saying to you right now at the get-go, don't take that temptation. And we'll talk a little bit about why that's the case. But there is a strong correlation between ISO and how they push the sensitivity of these chips and the types of noise that get embedded in that image. I would stick to 400 and 800 and avoid the temptation. If you want to go for more sensitivity, then you focus on your lens and you get a faster lens. And it's a lot more money, I'm sorry. But shortcutting it with software, my experiences, doesn't pay off. So anyways, that's just me. Someone else will tell me to fly a kite, whatever, but that's just the way I look at things. You need a camera to be fully manual. So astrophotography, there is no A mode. It's all manual. And so getting to know the camera as much as, and these cameras have a ton of features now. You don't need all of them, but getting to know your camera and experimenting with them. Don't use astrophotography as the first opportunity to use a camera. It's not going to work. So you really got to understand your camera and what it can do. Raw modes for astrophotography, that's the only mode you should ever be shooting in. There are some cameras that do RAW and JPEG. That's handy. You'll use up a little bit more data, but actually that's quite useful. A feature called mirror lockup. So a lot of DSLRs don't have that feature. Some offer, if you go to some websites, you can do an update to your camera, which will allow for mirror lockup. And why mirror lockup is important is because most of these have electronic shutters. And when the shutter slaps against the interior of the camera, there's a very minimal vibration that occurs. And if it's a short exposure, it'll ruin your picture. So I use self-timers and mirror lockup as a sequence in taking photographs so that you don't introduce any kind of mirror slap and vibrations. And as I said before, this feature is not available in a lot of DSLRs. So I know in my camera, I use an older Canon, and I had to go and find some others firmware on the internet and upload. And they came with a whole bunch of other features, which are kind of cool as well, like histogram manipulation and all kinds of stuff. You want a sensor cleaner. So I know a lot of DSLRs now have the ability to clean your sensor. So after every several frames or an evening at least, you'll want to clean your sensor. What it does is it opens a shutter and allows you to manually, with a bulb spray bulb, air bulb, clean your sensor, or it has another feature which vibrates the sensor to get rid of any dust that may have accumulated on the sensor. Handy feature. One of the, we'll be talking later on about flat fields and everything else, but you'll want to get in the habit of being super meticulous with all your equipment, your lenses and your cameras and all optical services. It almost sounds a bit anal, but it's really important because you wouldn't believe how much dust settles on your equipment after one evening. And even during a night of taking several photographs and later trying to stack them, you'll notice differences that occur. So it's one thing to keep in mind with regards to keeping the equipment clean. Any questions on that? Sorry.
What
I
about
have a
a
question.
sorry,
Yes.
what about a
Go.
mirrorless camera?
Pardon me?
What about a mirrorless camera?
So I personally don't have any experience with mirrorless cameras. I don't see why they wouldn't be effective. I just don't, I haven't used them. I'm sure they're fine. As long as they have some of the other features, I'm sure they would be okay.
Sounds good.
One of the things we're going to talk about later on is, oh, here it is here. So I'm ahead of myself. So just to continue on with the camera, you will have to decide at some point, and it doesn't have to happen right away, because to modify, you hear a lot about modifying a DSLR camera, and what you're doing is you're removing some of the filters that are on front of the sensor to allow for UV infrared. So right now, your camera is blocking certain spectrum of light and certain wavelengths, because otherwise your daytime photographs will look terrible. They'll be out of color sequence, be out of color calibration and everything. Unfortunately, for the night sky, that's not necessarily helpful, depending on the type of photography you're doing. So if you're going to get into deep sky region photography, where you're looking for hydrogen alpha, nebula and things like that, and wide field photography with that, you will have to end up modifying your camera. And there's people that will do that for you. I would advise against doing it yourself. I've done it myself, and it's doable, but it's a lot of work, and you can make a mistake and ruin your camera. So there are people who do that for you, or you can even purchase a camera that's already been modified. And there's a company in Montreal, I believe, up to find Lire de Nature, I think it's called. And there was a guy there that sells modified DSLR's camera, and that's where I got mine from. But otherwise, if you're not going to do hydrogen alpha photography specifically, and you're going to do mainly, constellation photographs, star trails, or just some nice night sky work, you may not have to modify it. If you're going to do Milky Way, I would modify it. The reason is because you have a lot of objects in the Milky Way that emit hydrogen alpha light, and you may want to capture those, but that's a personal preference. If you're doing aurora, you don't need to modify it. So depending on the kind of photography that you want to get into, you may or may not have to modify your camera. There's a lot of information on the web about that, and there's a lot of people will tell you one thing or other, but in my experience, once you modify a camera, it completely changes the camera. So you have to be aware of the settings that are there. If you want to do other photography with that camera, you will then need to create a library, or you'll have to have a gray card white balance, custom white balance set up on your camera, which is what I do. So basically, you take a gray card, you photograph, you store it as a white balance calibration, and then you can take photographs with that white balance, and it works fine. So, anyways, okay, did that intervalometer. So you need.
Sorry, one quick one. So
Yeah.
for the white balance, you don't have to set that every time you take pictures in?
In my camera, I can choose whether to pick up that white balance that I've already created. and
Okay.
add it to the photograph. So there are different features depending on your camera.
Got it. Thank you.
Right. An intervalometer is going to be really important. Uh, some new cameras have intervalometers built in, which is really cool. Some cameras have Bluetooth, which you connect remotely and allow it to connect to your computer or another device for intervalometer. I don't care how you do it. Mine's an old fashioned, you put a wire in there and it's an intervalometer that actually attaches to my mount. But something that allows you to control this exposures length, how many exposures, the delay between exposures, time sequencing, those kinds of things are totally necessary. If you can do it remotely without a cable, that's even better because then it doesn't introduce any additional vibrations if you're touching buttons or anything like that. That's kind of handy. Mine doesn't do that, but I know a lot of cameras do. So it's something to look to. If you have a built-in intervalometer, I'm not sure how I think about that because you end up having to press a lot of buttons and move the camera a bit. And I prefer to have something handheld or separate from the camera that I can control, stop, start, those kinds of things rather than getting close to the camera. I get paranoid when I get within 5 feet of my camera and my mount, even though it's a solid mount. It's just the vibrations, I just don't like it. So something that you can do separately is for sure to look at. And there's a lot of different intervalometers out there. It doesn't have to be really expensive, but if you have Bluetooth or control on your camera, that's really good. Otherwise, a wire that goes to a long wire that goes to a computer or a handheld intervalometer that you just can be remote from enough distance, and that's fine. The weight of the camera and lens, super important. So there are some lenses out there that are really, really heavy. They're good lenses, but they're heavy. And with the camera attached to it, it introduces a lot of weight. And then you need to look at what kind of mount you have and what kind of photography you're doing. You want to be really careful because if it gets too heavy, you could be out of balance with a lot of your equipment, and it's something to consider. We'll talk a bit more about that later on. So I wouldn't cheap out on a DSLR camera. There's a lot of low cost ones out there, but we're talking astrophotography. And one thing about astrophotography, it doesn't work well with cheap equipment. At least my experience. And I've gone through some cheap equipment, lost it. Someone else's swap meet things. So anyways, the lenses. Probably the most expensive part of everything you're going to be doing here is the lens. So there's a whole bunch of and a whole range of lenses out there, and you may have to invest in several different kinds. I would try to stay away from zoom lenses, although there are some really good zoom lenses out there, and stick more to telephoto lenses. Probably wide angle, you're looking at 18 to 30 millimeter. Medium is 50 to 135 millimeters, and then longer is 150 to 300. When you get to longer focal lengths, there's all kinds of other considerations that one has to take into. So if you're starting off in wide angle or astrophotography, I'd really recommend getting a nice wide angle a lens and a medium lens with f2, f2.8, f4 max. You want something that's going to take fast photographs, so you don't have to take long exposures. They're fast lenses, and that'll get you the results you want quicker without taxing your mount. And anything longer than that, because remember, you're going to have to stop down. And a lot of those lenses, you're going to have to, you can't necessarily go wide open. Some will allow you to do that, really good ones. But most you'll have to stop down. So even if it's an f2, you're probably looking at f2 at 2.8, maybe 4.6, which increases the length of your exposure and taxes your mount. So we're going to talk a lot about that later on, but it's some considerations if you're looking to start out here where you should look at what lenses. The glass is really important. there's lenses now that are made from ED glass, FPL 51 and 53, and a Japanese Ohara glass. Those are excellent. Like if you can get lenses built with those glass, it's expensive, but they're really good because they really cut down on chromatic aberration. So the different wavelengths of light come to the same focus versus a lot, and I'm talking on most telephoto lenses, they're gonna be terrible for chromatic aberration. So you want to look at glass that is O'Hara or 51 and 53 FPL. No plastic. There's a lot of plastic lenses out there. Stay within plastic lenses. They're terrible. They're going to give you what's called flaring. You don't want to deal with that. The other thing about lenses is that when the temperature changes, depending on how they're made and what the mechanical construction is, quite a few of them are going to change focus during the, if you're at the night sky and it gets really cold, they're going to start changing focus on you. So you have to be mindful of that and how not only the lens, but it's how it's constructed and the mechanical soundness of that construction. So there's certain lenses there that'll also, depending on the angle that you're shooting at, some will actually change focus because of the way, like if you have a ring at the top of your lens that you turn to change focus, you'll believe how often that can tweak a bit when you're shooting high up towards the zenith. So other things to consider in terms of mechanics of the lens. Just because it's good for terrestrial photography and daylight doesn't mean it's a good lens for astrophotography. I'll give you later on we'll talk about different manufacturers and what to look for. The ones that I have experience with. I can't speak to all of them for sure. Any questions on that part? Okay. Tripods. So as I said before at the beginning, you got to have a solid mount. You want to be able to do something that on the legs themselves, I mean, there's carbon fiber. I like to stick to steel or at least, heavy aluminum. And something at the bottom of the tripod that absorbs vibrations. So there's some tripods out there which have metal spikes that come out the bottom. If you're in soft ground, they may be useful, but I like the ones that have very good impact resistant, vibration resistant ends at the legs. Something that can be also adjusted in multiple directions so that you can level your tripod, because the ground you're going to be on isn't necessarily going to be level. So you want to make sure that you've got a good reference and that you have the ability to level your tripod. You want to be able to have a tripod that allows you to move very freely in alt-az mode. This is where you're looking at mounts that have the various heads on them. I'm finding it difficult, or I have found it difficult to find a mount with a head that doesn't move once you lock it down. So there are some heads out there that you can use that allow for you can lock it in place and then fine adjustments. It has little knobs for fine adjustments. Those are very handy because one of the frustrating things is when you get into higher focal lengths and you're going to look at the moon or a planet or something like that, or you're photographing something and you think you lock it in place, you let go and it drops out of the field of view. That's a problem with a lot of mounts. So just because the mount's solid doesn't necessarily mean, and it's expensive, doesn't necessarily mean the head is good. So you want to take your time and look at the head. You want to play with it and you look at, is there any play in that? When you lock it down, is there any play at all in that mount? There should be zero play. Even when you release the lock, is there any play in it? There shouldn't be any play. It should be smooth, and when you lock it, it locks in place. So often or not, even Manfrotto, you'll get a solid mount and they'll put a cheaper head on it. You want to stay away from that. That's a very common tactic to keep costs down. Adapter plates. The ones I use are with quick release. those are great. The last thing you want to do is monkey around with adapter plates in the middle of the dark and lose something, and you're messed up for the night. So something with a quick release, again, no play. There's some cheaper ones out there with a quick release. So you put them in, all of a sudden there's a bit of play. That'll ruin your night. I think I talked to alt-az markers. It's not really, we'll get into that a little bit later. I want to talk about tracking mounts and things like, oh, here we are, star trackers. So star trackers, probably for the first little while, when you're starting off in astrophotography, you won't be using a star tracker. But for certain kinds of photographs, particularly for longer exposure photographs, you're going to need a star tracker. So you're going to need to track the night sky. There's several in the market now, which are excellent, and they come with really good mechanics. You can essentially adjust for your RA and deck. They come with nice adapter plates. I use an Optron Skyguider Pro, and I've upgraded some of the mechanics to it. New head and counterweights and things like that, and it works really well. It does not go to, and my understanding of some of these cheaper, smaller star trackers, which are made for camera and lenses, the go-to is something to be desired. They don't all work that great. They're improving, but I don't think they're there yet. You want something with an internal battery that lasts at least 4 hours. You want something that's easy to move in a line. Some of these star trackers have clutches on them that are not very good. So what I'm saying is that when you're going to take your camera and position it at a certain object or a part of the sky, and you have to release your RA and deck clutches, they're hard to turn. And when you lock them down, they don't stay in place. So I find that Optron's good. Skywatcher is also good, but it depends on the model. So again, the go-to ones, you're paying for a lot. You don't need it, in my opinion. You should know the sky good enough that, you know, its go-to saves you time and aggravation. But if you know the sky good enough, especially if you're doing wide field, you don't need it. And there's also an app, which I'll talk to you about later on, that basically turns your star tracker into a go-to mount, and it works really good. And that's free. Counterweights. So this gets back to the camera and the lens. Most of these star trackers, if that's where you're going to go, if your camera is probably, you know, a couple of pounds, you're not going to need a counterweight. You're going to be fine, maybe even up to 4 or 5 pounds. Anything more than that, you're probably looking at a counterweight. These star trackers have a minimum 5 kilogram capacity, so you can't put a lot on it anyways. If you're going to be over that with your camera lens, you're talking about you're doing something different, right? So anyways. And some of the manufacturers I mentioned before have a wide range. These particular manufacturers made excellent mounts. There are others that make good mounts as well. I'm just not familiar with them. Any questions on that? How are we doing for time? We're already at an hour. Jeez. Okay, some more considerations. Thought this was going to be easy, eh? Lots of stuff. Okay, so batteries. You're going to be in the field, or you're going to be photographing at night. Your camera battery is not going to last very long, so you have to have an external power. And in most cases, you're going to be in a field where there is no commercial power, or may not be commercial power available, so you need a portable battery. And you need something with a decent amount of capacity. So like these cell phone battery packs and things like that, like, you know, they're not going to cut it. You need something. If you have, if you're opening up your lens with a shutter for, you know, a few hours in an evening, you're operating your mount maybe, or you have maybe even a laptop or something else to do it. You want to probably look at a lightweight lithium ion battery. There's lots on the market now. I've got a picture of one here. It's quite small and not too expensive. You can go bananas and pay hundreds of dollars for these things. You don't need it unless you've got big telescopes with computers and all kinds of stuff. That's not what we're talking about. Anything with a 10 to 15 amp hour range is going to last you several nights. So you're good to go with something like that. This model here is made by Mead, or used to be made by Mead. It's very handy. It's a lot of nice features on it. It has a DC output, 12 volt, but it also has 112 volt AC inverters built in, and it has USB-C and USB outputs as well. So you can power a number of different devices on there. And, you may have your camera, you may have different devices that you need to power, handy to have. If you're going to use dew heaters, in which case, unless you live in the right climate, we know dew is a big problem here. You're probably going to need a dew heater. That consumes quite a bit of power. This has different types of outputs that will work with the dew heaters. Really handy to have. Focusing, which again, we're going to have a whole section on focusing. Focus mask, batten off mask, something to invest in. I highly recommend it. It is really hard to focus in the nighttime with these lenses, especially depending on the kind of lens you're using. Some of them have a very, very finicky focus adjustment. You need a quick way of telling you if you've got precise focus. Batten off mask is probably the best way to do that. And we will talk more about that and how to use them later on. That's, to me, and you can get them on Amazon. They'll fit various lenses, very easy to use. Sky apps, as I mentioned before, I use the Ioptron Polariscope Align Pro. It's excellent. I think it's a paid for one for like $4 or $5. And it'll help you not only with polar aligning, which we'll get into, but it also will turn your sky tracker into a go-to mount. And it has a whole bunch of other features for finding objects and helping with locating objects and where they are and things like that. And it can mount right on your, the way I do it is I have a holder that puts my phone right on my lens. And you can manipulate your setup and know that you're pointed in the right area. It works really good. So we'll talk a bit more about that later on. Any questions on this chart? Okay, I think that's going to be it. This is the last chart before I get into members' contribution. So location, yeah. So probably the most time we're going to spend is finding out where are we going to shoot from. And again, it depends on what you're trying to shoot. I do a lot of my work in my backyard. I've got filters and all kinds of stuff, but if I'm doing wide field astrophotography, I'm not shooting from my backyard. It's just way too much light pollution, and I don't want to be messing around with filters and all kinds of stuff. I don't use filters other than my camera's modified. I will not use those for wide field astrophotography. I just don't. So again, location, you have to decide what is it you want to shoot. You're going to do star trails, Milky Way, deep sky object. You need to find a location that is of interest, but also will give you that horizon view of what it is you're shooting at. So you want to also look at how far you have to travel and when you have to get home. I mean, when I was younger, I'm not that now, when I was younger, I had no problems driving 2 hours during the week to a site, dark sky site, photographing till like 3 or 4 in the morning and coming back home and getting to work the next day. I mean, that's nuts, but I used to do that. I couldn't possibly do that now. Anyway, so you have to look at your energy level, your work commitments and everything else, and the proximity. So, we're always looking for locations that we can go to. I mean, every time a member posts something on the reflector about a location, I print it out and I stick it by my wall here. I got to try that site. And I got to, so I try to remember different sites because they're not easy to find. Use forecast weather apps, as I said before, and I spelt it wrong again. Astrophotography. I will fix that. Clear sky clock, clear outside, those kinds of apps to find out where it is you're going to be going for that particular evening for the weather. Again, the landscape. What are you going to be on, a hill, a flat surface, going to what's in that area? What is the light pollution like? So there's a great website called, I think it's light pollution. You just look up light pollution on Google, and there's a site that'll give you light pollution on a Bortle scale for the site that you want to go to. I use that all the time. And we're going to talk a bit about the Bortle scale and that out later on. You want to look maybe for a site that has artistic scene. We have a park next to my location here, Bronte. It's got some old barns, weathered looking. And if you line things up certain ways, you can get some really nice foreground scenery, particularly if there is a little bit of lighting that you put on there, and you create a really interesting effect. So location is going to be interesting as to what you want to get to. And then the Bortle measurement, as I mentioned later on. The other thing too is if you're going to a dark sky site, it may be a little bit a ways from the city. It might be colder, so you have to look at what you're going to be wearing depending on the conditions. And as I said before, you want to be comfortable. You want tables, you want to have a nice chair or something, maybe even a warm-up hut that you can use if possible. I don't know, but that would be nice. Any questions on that? Okay, and this is just a member contribution. I asked members if they could just contribute. So Fred Benedict sent me a photograph of a constellation he took with the Dipper. Very basic photograph, but you can clearly identify the constellation there. Great way to get started with regards to astrophotography is just to photograph the constellations and see what you can see and identify. I mean, I did that for a couple of years before I even got started with anything. So that's the first session. And if there's any questions and you feel you want to ask me, just send me an email. I'll try my best to answer them.